Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. EZ nomenclature requires that each carbon of the double bond bears two different substituents. If one carbon has two identical substituents, EZ designation is impossible and we assign none, N. Structure 1 analysis. The double bond indicated has one carbon bearing A, a phenyl group, and B, a benzyl CH2PH group. The other carbon bears two hydrogen atoms is equal to CH2. Because the terminal carbon has two identical substituents, H and H, EZ designation cannot be assigned. Wait, re-examining the structure, the arrow points to the internal double bond between the carbon bearing pH and CH2PH on one side and the carbon bearing pH on the other side. Looking more carefully, one sp2 carbon has a phenyl group and a benzyl group, the other sp2 carbon has a phenyl group and. Rereading, the structure shows pHCH is equal to C, CH2PH, where both carbons are disubstituted with different groups. Carbon 1, phenyl, pH, and H, carbon 2, phenyl, pH, and benzyl, CH2PH. Priority on C1, pH, priority on C2, pH, CH2PH. pH has higher priority than CH2PH since direct attachment gives C versus C, H at first shell. Actually, pH attached directly gives aromatic carbons. Assigning CIP priorities, C1 substituents, pH, higher versus H, lower. C2 substituents, pH, higher, direct ring, versus CH2PH, lower, CH2 then ring. Higher priority groups, pH on C1, top, and pH on C2. Looking at the drawn structure, both pH groups appear on the same side, both upper region. This would be Z. Answer, Z. Structure 2 analysis. The double bond has one carbon bearing two cyclopentadenyl groups, one above, one below left. Because this carbon bears two cyclopentadenyl substituents that are identical, or even if slightly different connectivity, they are both cyclopenta 2,4-DN1 while groups attached the same way, EZ cannot be assigned. The carbon bears two identical cyclopentadenyl rings, making EZ designation impossible. Answer, N, none. Structure 3 analysis. The double bond has one carbon bearing phenyl group and H. The other carbon bearing methyl CH3 and OC is equal to O CH3 acetate. CIP priorities C1 PHH C2 OC is equal to O CH3 oxygen beats carbon. The higher priority group on C1 is pH, on C2 is OAC. In the drawn structure, pH is on the left and OAC is on the right. With pH and OAC on opposite sides of the double bond, the structure shows a trans-like arrangement where pH and OAC are on opposite ends. Examining the geometry, pH is on the left carbon pointing left and OAC is on the right carbon pointing right. They are on opposite sides relative to the double bond axis. This means the two higher priority groups, pH and OAC, are on opposite sides is equal to E configuration. Answer, E. Therefore, the correct answer is 1-Z to -N 3E. The correct answer is shown on screen.